What are the chances of winning my hand? Almost every number we will go through is related to probability. Using probability in poker doesn't mean you're going to win every time. You won't. Probability is not good for short-term results. It is great for long-term results. The reason probability doesn't work well in the short term is because clumps of unusual things can and do happen, strictly by chance. It's possible if you flipped a coin, it could come up 10 times in a row. But if you flipped it 10,000 times, you would end up with close to 5,000 heads and 5,000 tails. That's the long term. That's when probability works. Limit is perfect for probability, and you need to know the numbers for no limit. You're going to use probability to win over the long term. Is there a rush? Yeah. You're going to experience both positive and negative rushes. You will get several good hands close together and may go an hour without getting a playable hand. On average, you would never experience a rush, but in the short term, the short run, things might not turn out to be average. A rush will happen for the same reason the coin came up 10 times in a row, by chance. The reason is because of something in statistics called random variation. You don't need to know all the mathematical background, but here's what you need to know, and I will say this with all deference to Mr. Doyle Brunson. You may never play as though you are on a rush. You may never keep ace-8 because eights are hot today, or play poor hands because the deck is warm, or because you're on a heater. You must play each hand as if the previous hands have no effect on the hand you're playing. That's because they don't. What happened in the hand you just played has absolutely no effect on what happens with the next. There is a plus you do gain when you are on a rush, but this has nothing to do with math. Many players will be apprehensive to go up against you when you're on a positive rush because most players believe in rushes. Not a bad time for one of your infrequent bluffs. Another thing, if you flip a coin 10 times and it comes up heads every time, is a tail more likely to come up on the next flip? If you said yes, wrong. The coin has no memory. Remember that clusters and clumps of unusual things can and do happen in the short run. If you looked inside the coin, you would see it has such a small brain, it doesn't remember. It just landed heads 10 times in a row and thinks, now I have to come up tails. When we dissect a card, we see it has even a smaller brain than the coin. You can't play a hand as though the cards have a memory. You don't need to know any of these numbers, but I want you to get an idea of how big the poker universe is. Pre-flop, there are 1,326 possible starting hands. Although if we neglect specific suits, which they should be, and we count those suited cards as a different hand from those unsuited, there are really 169 starting hands. By the time we finish this course, you will know all 169 hands pretty darn well. Once you have seen your first two cards, there are 19,600 different flops. That's a lot of flops. Once you see the flop there are, with two cards to come, 1,081 possible combinations of turns and rivers. Let's take a look at the relative magnitude of what you face. First two cards, 1,326 possible combinations, equivalent to 169 hands. On the flop, 19,600 possible flops. With two cards to come, 1,081 different possible combinations. If we take the turn and river separately, which is done in limit, there are 47 turns and 46 rivers. Now that you've seen some of the numbers of possible cards, this next graph won't surprise you much. It shows the degree of difficulty during each round of limit betting. It includes both Daniel's psych skills and the mathematical knowledge you will gain in this course. One thing I have to say about this graph, this particular graph that you're looking at right now, the flop shows as more difficult to play. And that's true in low limit. When you get to high limit, the turn is actually more difficult to play. And when you play no limit, the turn definitely is much more difficult to play. If there are 169 starting hands you can be dealt, intuitively it would seem if you played the top 84, that's the top 50% of the hands, you'd win half of the time. Well, that's so-so logic, but it doesn't even turn out close to that way. It turns out there are only certain hands that can be played which give you a positive expected value of winning, and that number of hands is well below 84. Sometimes probability and common sense aren't the same. One more point. Just because you can win or lose a hand doesn't mean you have a 50-50 chance of winning or losing. Thinking that way will cost you a ton of money. You go out and buy a lottery ticket, you'll either win the $2 million or not win. You know you don't have a 50-50 chance of winning. The same thing applies to your hands. You do not have a 50-50 chance of winning every time you play. Your chances are much less, and you must use probability to enhance your likelihood of winning. Some hands come up more frequently than others. Well, at first that doesn't seem logical. Let's think about it. How many ways can you come up with ace-king unsuited? You could have, and take a look at this particular graph, you can see that there are obviously 12 different ways ace-king unsuited can come out. How about ace-king suited? When you take a look at this graph, you see there are only 4 ways to get ace-king suited. 12 ways to get ace-king offsuit, and only 4 ways to get ace-king suited. Does that mean you're going to get ace-king unsuited 3 times as often as you get ace-king suited? Yeah, it does. How about pairs? Let's take queen-queen. Wow, there are only 6 ways to make a specific pair. So even though there are 169 different hands you can be dealt, you now know some hands will come up more frequently than others, so statements such as these are not going to surprise you. You're going to get ace-ace once every 221 hands. You'll get ace-king once every 110 and a half hands. You're going to get ace-king suited once every 331 and a half hands. And you're going to get a pair once out of every 17 hands.